Hello and welcome. I am your expert technical instructor. Today, we are embarking on a comprehensive, deep dive training session, specifically designed for exam AZ-400, designing and implementing Microsoft DevOps solutions. Let us begin our journey to certification success. Welcome to this comprehensive overview of the AZ-400 Designing and Implementing Microsoft DevOps Solutions certification exam. This exam validates your expertise in combining people, processes, and technologies to continuously deliver valuable products and services that meet end-user needs and business objectives. In this opening module, we explore the fundamental core of the DevOps journey. We must establish a baseline understanding of what DevOps truly represents. It is not merely a set of automated tools, but rather a profound cultural shift and a collaborative philosophy focused on breaking down traditional silos between development and operations. Transformation teams play a critical part in this organizational transition. You must identify key stakeholders who can drive meaningful change and define organization structures that natively accommodate agile practices. You will explore shared goals and establish timelines that align with broader business initiatives. The AZ-400 exam extensively covers two primary enterprise platforms provided by Microsoft: Azure DevOps and GitHub. Azure DevOps provides a comprehensive suite of services, including Azure Boards for agile planning, Azure Repos for source control, and Azure Pipelines for continuous integration and delivery. GitHub offers exceptional collaborative source control, GitHub Actions for workflow automation, and GitHub Advanced Security. To succeed, you must design a robust license management strategy to ensure cost-effectiveness while providing necessary access to all developers and stakeholders. Understanding source control is the bedrock of modern software engineering. We examine the differences between centralized and distributed version control systems, focusing heavily on working with Git locally. You will need to master basic Git commands, comprehend how to track changes, and efficiently manage repositories. Running commands like --git init and --git commit establishes local tracking of source changes before pushing them securely to centralized shared repositories. This flowchart visualizes the continuous DevOps lifecycle, emphasizing an ongoing, iterative loop of planning, coding, building, testing, and safely operating software. Building upon our foundational knowledge, we now transition into designing and implementing robust branch strategies and workflows. A critical skill measured in the AZ-400 exam is the ability to manage code collaboratively while minimizing integration conflicts. We explore several key branch workflow types, each suited for different project requirements. The feature branch workflow isolates new development into dedicated branches, allowing developers to safely innovate without disrupting the main production codebase. Once a feature is verified, it is integrated via a pull request. We also dive into the Git branch model for continuous delivery, which enforces strict automated rules on how and when code is merged into production-ready branches. Another prominent model is GitHub Flow, a highly flexible, lightweight workflow that perfectly supports agile teams making regular, rapid deployments. For large enterprise environments fostering an inner source culture, where proprietary code is shared internally as if it were open source, the fork workflow is absolutely indispensable. Implementing the fork workflow enables developers across entirely different departments to seamlessly contribute to a central repository without requiring direct write access, effectively mitigating security risks while simultaneously promoting innovation. Crucially, the AZ-400 exam tests your ability to thoroughly implement branch merging restrictions to enforce code quality. You will learn to properly configure robust branch policies in Azure Repos and GitHub, requiring mandatory code reviews, successful automated build validations, and explicitly linked work items before any code merges into critical branches. This proactive, policy-driven approach significantly reduces software defects. Creating an isolated feature branch ensures that experimental development is segregated from the main codebase, protecting production environments from untested code. This diagram thoroughly illustrates a secure pull request workflow, where strict branch policies flawlessly enforce automated build validations and mandatory peer reviews. With our codebase securely managed in branch workflows, the next critical step in the AZ-400 journey involves implementing robust continuous integration using Azure Pipelines and GitHub Actions. Continuous integration is the vital practice of automatically integrating code changes from multiple contributors into a single, cohesive software project. The exam emphasizes your ability to accurately describe the anatomy of a pipeline and flawlessly configure pipelines as declarative code using YAML. Transitioning from legacy classic Visual Designer pipelines to YAML-based pipelines is a major focus, as YAML provides strictly version-controlled pipeline definitions that systematically live alongside your application code. Understanding foundational Azure Pipelines key terms such as distinct stages, jobs, operational steps, and granular tasks is essential for success. You will learn to purposefully design and implement a comprehensive pipeline strategy that includes configuring targeted agent demands to unconditionally ensure your builds execute on the correct infrastructure. We comprehensively explore the significant differences between Microsoft-hosted versus self-hosted agent pools, and explicitly understand typical situations for purposefully selecting each. Furthermore, the exam evaluates your practical skills in implementing advanced multi-job and multi-configuration builds, allowing you to simultaneously compile and extensively test your application across completely different target platforms. To intelligently optimize pipeline performance, you must understand executing parallel jobs and properly estimate parallel job requirements based on team demand. Additionally, you must design a strategy for integrating functional test automation and code coverage metrics directly into pipeline runs. This declarative YAML snippet specifically defines a multi-stage pipeline, explicitly outlining the required virtual machine image pool and exact step-by-step CI tasks. The multi-job pipeline flowchart meticulously demonstrates how Azure Pipelines concurrently executes parallel jobs across distinct agent pools, drastically reducing build times. An indispensable component of modern DevOps architectures, heavily prioritized in the AZ-400 exam, revolves around infrastructure as code, commonly known as IAC, and the utilization of containerization. Managing infrastructure strictly through version-controlled code ensures absolute consistency, effortless repeatability, and rapid provisioning for all target environments. We comprehensively explore Azure Resource Manager templates, which provide a highly declarative methodology to define complex Azure resources utilizing structured JSON syntax. A JSON document functions as a logical collection of simple key-value pairs, accurately expressing underlying infrastructure as natively human-readable, text-based code. The exam rigorously tests your conceptual understanding of mandatory template components, such as configurable parameters, distinct variables, specialized functions, resources, and outputs. We additionally delve into Bicep, a powerful domain-specific language that serves as a highly modernized alternative to JSON for writing ARM templates with a significantly cleaner syntax. Containerization represents another core pillar of the AZ-400 curriculum. The assessment evaluates your unique ability to design an optimized container build strategy. You must carefully examine the underlying structure of containers and natively understand Dockerfile core concepts. Writing highly efficient multi-stage Docker files is unequivocally essential for seamlessly creating optimized, exceptionally secure container images. Once accurately constructed, these images are stored and systematically deployed to Azure App Service web apps or entirely different Azure container-related services. A multi-stage Docker file strategically optimizes container images by rigorously separating the initial build environment from the minimal runtime image, reducing attack surfaces. Here we examine the secure infrastructure as code deployment flow, where the automated pipeline sequentially retrieves encrypted secrets from Azure Key Vault before provisioning. As we methodically transition into the continuous delivery phase, the AZ-400 exam mandates a remarkably deep understanding of how to systematically design and execute highly resilient release strategies. Once a verified build artifact is successfully generated, it must be predictably deployed to target servers. We commence by thoroughly examining classical deployment patterns in stark contrast to fully modern deployment patterns, specifically including highly distributed microservices architectures. Modern software deployments extensively leverage advanced operational techniques to systematically minimize user downtime and operational risk. The certification covers implementing highly reliable blue-green deployments, where two entirely identical target environments simultaneously host different iterations of an application. Live user traffic is seamlessly routed from the legacy blue environment to the updated green environment immediately, once the new version is fully validated using deployment slots. We additionally explore granular canary releases, wherein a newly compiled version incrementally rolls out to a very small subset of live users prior to a complete release, empowering development teams to accurately monitor system performance. Dark launching and specific feature toggles represent extraordinarily critical architectural concepts. By smartly utilizing feature flags meticulously managed by Azure App Configuration, your deployment pipelines can safely push raw code to production, while dynamically hiding incomplete features behind configurable remote toggles, successfully decoupling technical deployment from business release. Swapping distinct deployment slots within Azure App Service facilitates a seamless blue-green deployment, instantaneously redirecting active web traffic to the newly validated build. The canary deployment diagram brilliantly illustrates Azure Traffic Manager, systematically routing a fractional percentage of user traffic to a new release for initial validation. Delivering software functional updates rapidly is frankly only half of the overarching DevOps battle. Maintaining long-term architectural maintainability requires exceptionally vigilant code quality management. The AZ-400 exam comprehensively emphasizes identifying, measuring, and proactively managing accumulated technical debt. Problematic technical debt inevitably accrues when agile teams mistakenly prioritize rapid continuous delivery over optimal underlying code structure, eventually leading to massive feature complexities. You absolutely must understand how to analytically examine code quality and properly utilize software complexity and quality metrics to objectively assess the fundamental health of your collaborative codebase. Integrating specialized external code quality tools securely into your deployment pipelines, such as SonarQube, reliably enables the continuous, automated inspection of code quality, effortlessly detecting critical software bugs, architectural vulnerabilities, and structural code smells. Another fundamentally critical topic is meticulously planning highly effective code reviews. Structured peer code reviews systematically foster team collaboration and rigorously ensure strict adherence to standardized coding practices. Pushing beyond basic functional quality, advanced application security must be natively integrated directly into the foundational developer workflow, a vital modern concept broadly known as shifting left. We comprehensively explore GitHub Advanced Security, which provides indispensable proactive features like automated secret scanning, upstream dependency review, and static application security testing. This seamlessly integrates continuous inspection within the DevOps lifecycle. Integrating powerful code QL analysis natively into a GitHub Actions workflow rigorously enforces the shift-left security methodology by automatically scanning pull requests. This specific sequence systematically shows end-to-end traceability, demonstrating precisely how a single code commit is flawlessly tracked through the build phase to final release. In our highly crucial final module covering the rigorous AZ-400 exam, we exclusively focus on the absolute imperative of securely integrating modern identity management systems and fully fortifying your comprehensive DevOps operational environments. Foundational security simply cannot be an afterthought. It undeniably must be organically interwoven directly throughout the entire continuous software development lifecycle. You will be explicitly tested on your applied ability to securely design and implement robust granular permissions and structured security groups natively in Azure DevOps, absolutely ensuring the foundational principle of least privilege is strictly applied to enterprise projects, source repositories, and deployment pipelines. Similarly, you must conceptually understand how to securely design and meticulously implement permissions and collaborative roles strictly within GitHub. Securely integrating these foundational platforms with centralized identity management systems is indisputably essential for maintaining broad enterprise security. The exam thoroughly covers integrating GitHub organizations with single sign-on functionality via Microsoft Entra ID, permanently centralizing overall identity governance. Furthermore, we precisely examine workload identities and the highly secure implementation of automated managed identities. By properly leveraging Azure Key Vault alongside Azure DevOps Secure Files, you dramatically improve token management. We invite you to consistently like this video, directly subscribe to our channel, and immediately visit quicktechie.com for premium certification prep, including extensive Q&A banks, dynamic ebooks, insightful audiobooks, exclusive training, and expert interview guides. Creating and precisely assigning an automated managed identity explicitly allows your deployment scripts to securely access target Azure resources without relying on static credentials. This sophisticated architecture diagram outlines the secure authentication path, where a modern pipeline dynamically utilizes workload identities to obtain temporary access tokens.